Good evening, students. Today we are going to learn about the Newton's laws of motion, or also simply called as laws of motion. Student, these laws of motion are dealing with the forces. There are three laws of motion which is given by Newton's. Therefore, it is also known as Newton's laws of. So first we will start with what is force, the definition of force, the type of force, means balanced and unbalanced force, then the laws governing this force that we will learn. The laws governing this force are three, called Newton's laws of motion. A student, what is force? So regarding this force, in your earlier standard you might have heard or learned any kind of push or pull is
Pull of an object.
listen. So any
Sir, pull of an object.
push or pull, I'm getting, please listen me today rather than interfering. I'm getting that you people have learned or you people are knowing, but please listen, everything I have to revise. Any push or pull, okay? But a student in class 9th, this definition is not sufficient. If you are writing just push or pull, you will get 0 marks, okay? So do not mug up this definition at class 9. At your level the definition get changes, though ultimate inference is regarding the push and pull. So what is that? Force is considered as any agency or any influence which is able to change the state of an object or tries to change the state of an object. What does it mean? It means you just consider a book is placed over a table. So if you are applying certain push or pull, if the push is very gently, it is able to move, okay? Though earlier it might be at rest. This is the book. So when it starts moving, means whatever the influence or the agency you have applied to change the state from rest to motion, that is called the force. Means whatever you have applied, that is called force. Even it is possible that this V may not be 0, or it may be possible that even if you are applying the same push, but to the lesser extent, it will not move, though you have applied the pushing. So that push is also called as force, though the state have not changed. In this situation, it is called as, it is tending to change the state, because if the push is increased, this object will start moving. So in this case, the state is changed. State changed. What was the earlier state? The initial state was the rest, and it have gone to motion. Rest to motion. So rest and motions are the state. Another, it is possible that this body is not changing its state, means the V is, means the body have changed the state that I have defined, means V is produced in this body. So V was not equals to 0 in this case, but if V is equals to 0, means body is still at rest. So body remain at rest, remain at rest. So these are the two possibilities when the force F is applied over this body. So remain at rest means no change in state, but the force is applied. This force have a tendency, or means though the force is tending to change, In this case, a state have not changed but have tending to change or tendency to change. Why the body have not changed the state? Because a frictional force is generated here in the opposite direction that is able to balance it. Say if you are putting or applying certain force over the wall will not move. Even if you are pushing any wall with certain force, the wall will not move or the wall will not destroy. But if you apply very
Yes,
high
sir.
force by means of the current or other thing, the wall will destroy. Okay, so
Break.
considering this, yes, tell me. बोलिए क्या बोलना चाहते हैं? Yes, tell me quickly. Today we have to finish a lot of syllabus. हाँ हर्षिल बोलिए क्या कहना चाह रहे थे आप?
नहीं सर, वो बोला कि वॉल टूट जाएगा क्रेन से करने से, पुश करने से।
अरे आपके पुश करने से वॉल टूट जाता है क्या? Just by applying certain force by your palm, the wall is not able to destroy or not able to break. Okay, though you have applied the push, means the object have not moved, but if the force is increased, say 100 people are applying the push, or with the hammer you are applying that push or that force, the wall is able to move or able to destroy. Okay, so therefore this force at your level is defined as like this. So what you have to write the definition is that is like this. So force, it is an agency or also called as influence or influence which have the tendency to change the state, which can change the state of body or have tendency to change the state of body. A state of body. A student, here two important terms are there. Either the state of body have changed, a state of body, either this have changed or the body have not changed their state, but they have just the tendency means trying to just change the state. So just understand once more, let me draw one more figure. A student, consider a ball is laying. Okay, you are applying very little force. So initially the ball is at rest. So initially at rest, but on applying the force it start. So finally it come into motion. On applying this external force F. Okay, so it is this one, means rest to motion. It is one possibility. The next one is, so while playing the cricket, you are observing that the ball is initially moving toward you. Consider this is the speed v. So initially in motion, but finally come to rest. So initially in motion and finally come to rest. So rest and motion are the two states. When it is possible, while you are putting some hurdle, means you are just pushing it or just holding it in your hand. Okay, ultimately it will come to
hand.
rest. So it is one kind of state change, and second one is representing the second kind of state change. A student, it is possible that there is a big block or a stone is there, you are trying to push it, but initially at rest, but on pushing it remain at rest, though pushed. So such a case where you are applying the force but you are not able to change the state, means though rest initially and remain at rest. So in this case, this force have the tendency, or this force F have tendency. Tendency means it can try. Simply it means that. But better, what is the tendency? To change the state. To change state. Why? Because if this force is increased to certain amount or to beyond certain limit, then this stone will start rolling. Okay, or in place of this heavy mass, if the smaller stone or a small ball is there, with the same force it is able to move. May this force have the tendency. So that's why the term tendency is equally important. So this is the new definition at your level that you have to learn. Okay, students, so please do not forget. So either it is able to change the state or have the tendency to change the state, right? Force. So what are the different states and the tendency? Students, keep in mind. So rest to motion, or motion to rest. Rest, remain at rest. Motion, remain at motion. So in these two conditions, there is only tendency. And this case, there is a change occur. Okay, student? When the force is applied. So these things are explained in our figure. A student, so definition of force means the influence or agency, means externally applied something which is able to change the state, means if the body is in rest, it is able to convert into motion, or if it is in motion, then it is able to convert it into rest. Or there is another thing is that, say motion initially at lower speed, say 2 meter per second, but applying some force, this motion, now the speed have increased to 5 meter per second. So even when the speed is increasing, so that is also the change. So increase in speed or velocity, increase or decrease in speed or change in velocity. Now a student, velocity is a vector quantity. So that change may occur due to the change in its magnitude, or maybe due to change in its direction. Means wherever acceleration is produced, then always there is a force. So how is that? It is given by Newton's second law, that we will learn. A student, So this force is a vector quantity. Means the vector algebra have to be followed. Means the two opposite forces can cancel each other. Say this is the object. On this, 2 Newton is applied from left to right, and 2 Newton is applied from right to left. Then this will remain at rest. So this force F1, which is from left to right, and F2 from right to left, if you add this F1 and F2, it is a vector quantity, so sign have to be considered. So this is 2, and this have to be taken in negative way, -2. Ultimately it can give you the 0. So this vector addition regarding basic thing we have learned in our chapter 1. So vector algebra have to be followed. Like you might be observing, you just take a ball in your hand and push with certain force in this direction and certain force in this direction, the ball is not able to move. Okay, though applying the higher force it may get compressed. Next one is unit of force. Is the unit of force what we are taking. So it is simply called as the Newton, denoted by capital N, and this Newton N, if we are taking the 1 Newton, it is given by 1 kg moving with acceleration of 1 meter per second square. So from the second law we will see this. So this is our SI unit, SI or MKS unit. A student, if we consider the CGS system, then it is called as dyne, denoted by D, in which 1 dyne is given by, in place of kg we need to take gram, in place of meter we need to take centimeter, and then per second square. How this is coming? This we will see from the Newton's second laws of motion, how this unit is coming. This is our CGS unit. Students, you have to keep this Newton and dyne in your mind for MCQs, because it will be asked what is the unit of force. So whether it is written as Newton or kg meter per second square, this may be written like this also, kg meter second minus 2, applying mathematics, both mean the same thing, whether this or this. Okay, so dyne or gram meter, in place of meter I need to take centimeter now, then second to the power -2, this is representing the other. Okay, so unit may be asked. A student, now the type of force, regarding type of force, there is broadly 2 kinds. One is called the balanced force, and the second one we have to learn is unbalanced force. Students, what is this balanced force and unbalanced force? I will write the difference here. So let me take this balanced force on left hand side and unbalanced force on right hand side. So we are going to write point by point. A student, both are the force, but we have to keep in mind balanced force means if more than one force is acting, then this situation of balanced and unbalanced force arises. So first we have to understand this type of force. This classification is for more than one force. So these balanced and unbalanced force are for more than one force applied on a body. Means for defining this balanced force and unbalanced force, I shall must take more than one force which is going to applied on a body. Let us consider this is any object in which from left to right you are applying a force F1 is equals to 5 Newton. Say this is a block which is placed on a table and one of your friend is pushing it while from one side, while your other friend is pushing the same block with the same force, say F2, 5 Newton, exactly opposite to the first force. Then whether this block is able to move. So in this case, what we are observing, the block will not move, will remain in same state. Same state means it is, if it is at rest, it will remain at rest, or if it is in motion with uniform speed, then it will continue to move with the same speed. Students, so this block will not move. I am considering the block initially at rest. But if you are taking the same block, one of your friend is moving it from, say, not from left to right with a force of 5 Newton. But your other friend is moving this or pushing this with a force of only 3 Newton. Means one of your friend is pushing with 5 Newton, means applying more force, while the other is applying lesser force in opposite direction. Ultimately, the more force is able to push this block in the direction of lesser force. So in this case, this block is able to move rightward, means in the direction of higher force. So with not the 5 Newton, with a net force of 2 Newton. Because this 3 Newton will get cancelled from this 5 Newton, still we will left with this 2 Newton. So with this 2 Newton only, this object is able to move rightward. But here, body will not move. Means what we are observing, if equal forces are applied in opposite direction, then body is not moving, means the net effect of this force is becoming zero. So such a situation in which the resultant or net effect of all the applied force becoming zero, then such a forces are called balanced force. So right, the definition now. So the forces, the applied forces, student, this is not a single force but more than one force. That's why I have written forces, more than one, are such that its net effect, so either it is written as in the term of net effect at your level, or this net effect in higher standard is called as the resultant, or its resultant is 0. Means no effect can be observed. So if the net effect is 0 or resultant is 0, then such a forces are called balanced force. Means equal and opposite forces. So write down the example. Equal and opposite forces, they are the balanced force. Here I have drawn in the figure F1 from left to right 5 Newton, F2 from right to left also 5 Newton. It is this one. It need not be only the pair of force, it may be more than 2 force also. Let us consider, say 3 Newton is applied from left to right, 3 Newton also applied from right to left, 2 Newton is applied upward, and 2 Newton is also applied downward. In this case, we can observe that this 3 Newton is cancelled by this 3 Newton, left right is cancelled. Also, the upward and downward, these 2 Newtons are cancelled. So in this case, still the cancellation of all the forces. So the forces, write this point, the forces cancels each other. But if we come to this unbalanced force, in this case the net effect is not going to be 0, but it have certain net effect. Like in this figure, this 2 unit is the net force or net effect. So such a forces whose net effect is not 0, then they are called as unbalanced force. So right, student, the applied forces are such that its net effect is net effect or resultant. Resultant is not 0. Means what? These forces do not get cancelled. So effect of forces means the different forces applied is not cancelled. So there is always a net force in this case. So body moves or tend to move in direction of net force. So either it will move or tend to move, means have the tendency or try to move, it means tend to move in direction of net force. Direction of net force. Okay, students? So if the two opposite forces are not equal, they are unbalanced force. Example, opposite forces not equal. Opposite forces are not equal. If the opposite forces are acting and they are not equal, then it will be the unbalanced force. There could be more than two forces, like if it is a three force, let me take this as 2 Newton in at certain angle, someone is pulling downward with 3 Newton, and even leftward with 4 Newton. Here we can observe that these three are not cancelling each other, therefore the net effect will be there and the body will surely move in certain other direction. Okay, student. So this was about our balanced and unbalanced force. Student, you have to keep these differences in mind. Balanced simply means the net effect or resultant is zero. For unbalanced, the net effect or resultant is not zero. Here these forces are able to cancel each other, but here these forces are not cancelling. Okay, student? So by this you can observe. Getting? So even force are applied and body is not able to move. In that case, we can say the body had tendency only, okay, but it is not moving. So in this case, or in this balance force, it gives only the tendency. You can understand like this, it gives only tendency. So it gives tendency to move, but the body will not actually move or not change in state. Unbalanced force is there, then body will surely change its state. So it can change the state. Okay, it is this one. So ultimate effect of unbalanced force is to change the effect, but the effect of balanced force is just to give the tendency. Body will actually not change its state, but it just gain a tendency and try to just change the state, but the body will not change its state. But not change its state. So these are the differences that you have to keep in mind. So have the tendency, that is the ultimate effect of this balanced force. When the force is applied, the body will not move. But if the different forces, means non-cancelable forces are applied, the body will change its state. So it is about our force. Now, what are the laws governing these force? So laws means the physics rules governing these forces, means by which law we are able to understand about the force. So a study about the force is the cause of motion, is called dynamics. So force is the cause of motion. Here we have seen, when the force is applied, the body is there, and if the force is applied, so either it can move. Initially I am considering this at the rest, or it will tend to move. So but if the body is already in moving situation, means it is in the motion, then the force is applied. Say the body is also moving in this in the same direction in which the force is applied, its speed will increase. Speed increases. Okay, or its direction will change. Direction changes. A student, while the football is coming closer to you and you are just giving a kick, means what? You are applying external force to change the direction of ball. So it is like this. So what are the laws that is governing? So there are three laws which is governing this force. These laws are, so right, three laws given by Newton, which explains if the body is at rest and force is applied, what will happen? Or if the body is in motion, then force is applied, what will happen? First law gives that. The second law gives how much force is required to change the state, say to increase the speed. Or if certain amount of force is applied, then how much will be the change in their momentum? This thing. The third law tells that when a force is applied on a body, then automatically a reaction force is generated over the applied system. Say you are pushing by your hand, then automatically the wall will apply a force on you, on your hand. It is called as the third law. So there are total three laws. So three laws given by Newton called laws of motion. So it is also called as Newton's laws of motion. So let us start with the Newton's first law. Students, this Newton's first law is also called as law of inertia or law of inertia. Inertia is nothing but inertia is the other name of mass. Inertia is the tendency to remain at the same state. So inertia. So this first law deals with the inertia. This first law tells that if the body is at rest, it will try to remain at rest unless or until it is applied by external force. Like you are observing that your football is just anywhere in your playground. Say in morning you have observed. Unless or until someone have kicked it, the position of football will not change. Okay, it will always remain there. Say your table is laying at one of the corner of your room. Can the table automatically change its position to other corner? No. For changing the position of table, what is required? You have to pull it to the other corner. Means some force is required. So this statement is called the Newton's first law. So this law is given like this: a body will remain in its state of rest or uniform motion, remain in its state of rest or uniform motion. A student, uniform motion means speed is the same. So speed is constant or with constant speed. It simply means that it is not the velocity, but it is the speed, because velocity, if there is change in direction, that can give the velocity. So right, constant speed, constant speed. uniform motion without changing direction. Changing direction means if the body is at rest, it will remain at rest. If the body is in motion, keep in mind it is uniform motion, means it is not accelerated. The body is covering equal distance in equal interval of time without changing direction, unless or until external force is applied. Means if it is at rest, it will remain at rest, or if it is in the motion, it will remain in motion unless or until external force is applied. This is very important. Means maintaining the state, maintaining the state. So student, maintaining the same state is called inertia. Okay, means the body have tendency to remain in the same state. This state could be either rest or motion, or if the body is changing direction, it will need some external force. So because of this, maintaining the same state is called inertia. This law is also called as law of inertia. So this way, this Newton's first law gives two important things. Rather not two, but better to say the three. What is that? So if the body is at rest, it will try to remain at rest. It is called as inertia of rest. So right, it gives the definition of inertia. Definition of inertia. What is inertia? Inertia is maintaining the same state. This means it will remain at rest or remain in motion, means the state will be maintained. So it gives the definition of inertia. Now this inertia can be for the rest or can be for the motion. So therefore, we can define these two or three things basically. Two are important. One is called inertia of rest, and the other is called inertia of motion. Okay, what is this inertia of rest? A student, write this. Inertia of rest. A student, this inertia of rest is the observation or conclusion or outcome of Newton's first law. So we are discussing this first law. In this, under this first law, we are defining this inertia of rest. This inertia of rest tells that body at rest will remain at rest. Yeah, tell me. Remain at rest unless acted by, acted means applied by external unbalanced force. External unbalanced force. Means say a book is laying on your table, it will remain at rest. Okay, the book will not move automatically from the table. Say a ball is rolling over a horizontal level, it will also continue to roll. That is called inertia of motion. That we will see later. A student, this is at rest, whether it is a book or whether it is a ball, it will remain at rest. But if you apply some force here, then only it can move. If this applied force is zero, the body will not move. So external force is required to change the state. Okay, so for to bring a body from rest to motion, external force is required. We also have to keep in mind, say if the body is initially at rest and applying 5 Newton from left to right and 5 Newton from right to left, the body will again not move. Therefore, just applying the force is not sufficient. Rather, the force or the applied force must be unbalanced. So it will remain at rest. But for this body, 5 Newton is applied from left to right and 2 Newton is applied from right to left, then this will start moving. Okay, so these are the situations that we have to keep in mind, though initially at rest. So this inertia of rest is very important. What is that? If the body is at rest, it will try to maintain its state of rest. How practically we are observing this? So right, practical observations. So right, practical or daily life observations. A student, you are observing that, consider you are sitting on the bike or scooty of your friend. You are, so it is one of your person or fellow who is holding this, and you are just sitting here. Okay, it is you or your other friend who is just sitting here. A student, so initially let us consider this bike is at rest. So initially rest, then you start motion. What is your observation? You might have observed, if you are in the back side, then you will observe that once the bike is started, your head is leaning backward or your head get tilted backward. Why so? A student, it is because once this is starting, this bike is going to start, then while starting, this fellow along with this bike will start moving. So it gains some speed, but the upper portion, means like this portion, it is free. Means it was initially at rest, it will try to remain at the same position, but the lower portion or lower part, say the leg and the lower part, will start moving once the bike started moving, but the head and other part will try to remain at rest. This way the bike have moved a bit ago, but head will remain at the same position, so it appears that our head is falling backward. So right, lower portion moved forward, but upper portion or upper part remain at rest. But since this upper part is connected with the lower part, so ultimately this will try to pull the adjacent layer. Lastly, all of this will start moving and appears as falling backward. Okay, so the practical observation or application is the passenger falls backward when the car or vehicle is started. So note that point. So passenger falls backward when it need not be only the bike, it could be the train, it could be your car, when vehicle start moving forward. It is this one. So this is one of the application or important application. Now we have to go for the other kind of inertia called inertia of motion. So write it. Inertia of motion. A student, this motion means the uniform motion. So body is under uniform motion. Uniform motion means speed or rather velocity is constant. So in this case, when the velocity is constant, acceleration value is 0. That we have to keep in mind. Means no acceleration. Such a motion is called uniform motion. This thing we have learned in our chapter 1. So this law tells that a body in uniform motion, a body in uniform motion will continue to move with same speed, will continue to move with same speed, or you may write this as the velocity, that is the better term, because there is no change in direction unless it is acted by external unbalanced force. External unbalanced force. Students, we have to observe carefully. Means here initially the body is moving. Say a ball is moving or a car is moving with certain speed. This speed is constant. That we have to keep in mind. So if external unbalanced force is applied, then its speed can be changed. If there is no any external force, then this speed will remain the same. So if F applied, then its speed or rather velocity v changes. Means if the body is in motion, it will try to remain in motion unless or until external unbalanced force is applied. Again, the force must be unbalanced. If the force is balanced, it will not change the state. What are the applications or observations? Students, we are observing that when sudden brake is applied by the driver, the passenger falls forward. Why? Because when the brake is applied, the lower portion come to rest along with the vehicle, but upper portion, which what is motion, will continue to move. Hence, it will try to move forward and fall forward. So, right, the passengers falls forward when says sudden brake is applied. Okay, is applied in vehicle. Students, so how the MCQs are framed? MCQs are very simple. Say passenger falls backward due to option A, only inertia of motion. This will be written. In B, inertia of rest will be written. C, say passenger falls backward. The both A and B, and in option D, none. What is the correct answer, student?
Inertia of rest.
Yes. So you have to keep in mind, falling backward is because of inertia of rest. Falling forward, inertia of motion. So this is for the backward fall. Backward fall. For the motion, it is it gives the forward fall. Means fall in the direction of motion. So here it is, fall opposite to motion started. Motion started. Okay. Here it's fall in direction of motion. Already the motion is going on in the same direction, it will fall. Okay, student. So this is important question. It may be the definition of force is important. The definition of balance and unbalanced force are important. Unit of force are important. So this was all about our the first law. So what we are getting from the first law, students? We are getting, so next question is like this, or the MCQs are framed like this. Write down the question. So Newton's first law gives option A. Say definition of force. Son of force. B, definition of inertia. C, both. D, none. A student, whatever the definition of force is there, the same is this Newton's first law. Because if you observe it carefully, what was definition of force that we have written? Even this definition of force was given by Newton himself. See here, again, this definition also tells that, so which can change the state. Are we getting? So change this state means inertia is either going to change, okay, or inertia is to be retained. So this force is also in the term of inertia itself, or force is defined in the term of Newton's first law also, or Newton's first law itself gives the definition of force. So this definition is from, so it is the base of Newton's first law. So therefore, if the question is framed like this, so Newton's first law gives what? Then it can be both.
Both.
Are you getting, students? So the correct option is our option C. So this
C.
way you have to write the answer or mark the answer correctly. So this was all about our Newton's first law. Now let us go for Newton's second law. But before going to Newton's second law, we have to learn some new physical quantity called momentum. So for this Newton's second law, we need momentum. Momentum. It basically tells that momentum change is required. Change. So first we will understand what is momentum is required. It is one thing. The second law gives the measurement of force, or the formula or measurement of force. This force is given by mass into acceleration. So this we have to prove. What is this momentum? So momentum is defined in the term of mass multiplied by speed, denoted by P. Okay. So P is equals to mv, or mv is equals to P. Okay. So these two things we have to understand. So let us first start with momentum. What is momentum? A student, momentum is also very important. It is also asked. So momentum is like speed, velocity. Momentum is also a new quantity in physics, which is the product of mass of a body with its velocity. So it is product of mass and its velocity. Get it? Say if a body is there, we have learned that it is moving with some speed or with some velocity v. V is a vector quantity. It has some mass. So if we take the product of this mass and velocity, we are getting the quantity called momentum. So right, momentum is given by mass into velocity. In a strict sense, it is the velocity, but speed is also magnitude of velocity. This we have learned in chapter 1. Or speed is same as velocity if the body is moving on a straight line without changing its direction. Okay, student? In symbol form, this momentum is denoted by P, and this mass is denoted by M, and velocity is denoted by V. This V is a vector quantity. So putting the arrow over V, this momentum P will also be a vector quantity. So it is the formula. In magnitude form, sometimes this arrow is dropped, simply mass into velocity is written. Mean the same thing, just only taking the magnitude. A student, what this gives basically? If the body is moving with some speed, what is the total influence? Say a tennis ball is moving toward you and you are just stopping it. To stop it, you will get certain jerk on your hand. But with the same speed, say 10 meter per second, if an iron ball is moving toward you and you want to stop it, then what is the effect that you will feel, or how do you feel? You will feel more thrust or more jerk on your hand. Why so? It is because mass is involved. Means what? When mass is multiplied with velocity, it is giving some new kind of quantity. That is giving the total effective motion. Okay. So this mv p or mv gives the effectiveness of motion. Means how effective of a body. If a body is moving, how much effect it will put. Okay. So this momentum gives that thing. If there is any change in momentum, then the force is generated. So right, if speed or velocity is 0, it means what? P is equals to the body have mass multiplied by 0, it is 0. Means the body at rest, what is its momentum? Momentum value is 0.
0.
Right? For a body at rest, it is very important. For a body at rest, its momentum is 0. It is asked in your MCQs. Okay? If it is at rest, momentum becomes 0. Because V is 0, P, mass into velocity, is also 0. If the speed is changing, so right, if velocity V is changing, then certain force must be generated. Then force arises. So how is this? This we have to understand. A student, here we have considered a body with mass m moving with speed v. But it is possible that I am taking a long road in which the body m initially moving with the speed u. So at this time, you may call this was the time at say 1 o'clock you observe it. Then if anyone is asking what is the momentum of this body at this time, You may call this as P1 or initial momentum Pi. It is m into u. By some force or by applying the accelerator, the same mass is now moving with some other speed v. Then its momentum value will also change. Here this v is greater than u, or maybe possible the v is less than u, that is v is not equals to u. Then at this time there will be new momentum with this body because of its changed speed or velocity. So these are the two kind of momentum that we are observing. Okay, student. Now what is the difference between these two? Here let me consider v2 v is greater than u. This implies the momentum 2 will be greater than momentum 1. Now while this momentum 2 is greater than momentum 1, then this difference means P2 minus P1 can be calculated. So this P2 minus P1, this gives what? The change. So this is the change in which quantity? P is denoting momentum, so it is change in momentum. Okay, student. So we have to understand the new topic called change in momentum. So write this. Change in momentum. Students, change in momentum means it is nothing but it is difference of momentum at different time. At different time, or maybe a different speed. Example, I am considering the body m, which was initially moving with speed v1, I may denote. Now the same body m have reached to speed v2. So in this case, the momentum p1 is denoted by m into v1, and this p2 is denoted by m into v2. Okay, it is also possible if you are denoting this v1 by u, then it will be mu, v2 by v, then mv. That denotation we have done earlier. So it is this. While changing from this to this momentum, initially this p1 might be at certain time. At that time in clock, the time was t1. But this new momentum, this is observed at time t2. Okay, like here I had denoted the 1 o'clock, and this was the observation at time is equals to 2 o'clock. Okay, so the change means 1 o'clock to 2 o'clock means the time interval is our 1 hour. Okay, students. So during this time interval, then if you are observing, in that case, so considering the time interval, if you are dividing the change in momentum by time interval, then that will give us the rate or rate of change that we have learned earlier in our chapter 1 also. So the time interval delta t is given by t2 minus t1. In chapter 1, we have learned this time interval may be simply denoted by t itself. Okay, then the change in momentum in this case denoted by delta p, it is called a change in momentum. it is the difference of momentum, means it is your P2 minus P1. So this delta P, P2 means mv2 minus mv1. This we may write. If the masses is or the mass is also varying, then m1 and m2 we need to take. So it is this one. So this was our change in moment. It is the first thing that we have to keep in mind. Another one, if this change in momentum is denoted by the time interval, this delta t, so this becomes rate of change. Rate of change of which quantity? It is the momentum.
Momentum.
This is same as what we had defined the acceleration as rate of change of velocity. So rate of change of momentum will be given by how? So rate of change of momentum so this rate of change of momentum denoted by delta P by delta T. Okay, students? Now what is this delta P? Delta P is nothing but it is our P2 minus P1. Delta T, it is also T2 minus T1. If the time in clock is given, you can take the difference to get the delta T. So above one may be mv2 minus mv1 if the mass and velocity of the body is given. If this time interval is denoted by simply the a small t, then it is simply like this. So this is called as rate of change of moment. Okay, student? Now, if we observe carefully, if say this V2 is taken as V and initial speed V1 is denoted as U. What does it mean? Means I am considering a mass which was initially moving with the speed or velocity U, but later on the velocity have changed to V. It simply means that. So the mass remains the same. From here to here, the time interval or time taken to change the speed from U to V is T. Then this rate of change of momentum can be calculated just by substituting these values. And this rate of change of momentum is called as force by the second law of Newton. So then rate of change of momentum or the force, this force is what applied to change the speed from U to V. So this is the force applied. In fact, the speed have changed means this force must be the unbalanced. So it is the unbalanced force. So the unbalanced force is given by rate of change of momentum. So therefore, the force applied or the force in this case can be measured by delta P by delta T or P2 minus P1 by T2 minus T1 is equals to mv minus mu divided by this T. Taking this m outside, mv minus u by T. Now a student, what is this v minus u by T? This is our acceleration. Very good.
Acceleration.
So since v minus u by T is our acceleration, it means the force F is given by this formula. So this way, F is equals to ma is proved. How we are getting? So this analysis or this thing is called as Newton's second laws of motion. So Newton's second laws of motion, the definition is like this, or the statement is like this. So right, Newton's second laws of motion. So how is the definition? The definition is like this. So it tells that when an unbalanced external force is applied over a body, the force is generated. I mean, when external force is applied or the force generated or applied over a body, then there is always some change in moment. And the measurement of that force is given by the rate of change of moment. Okay, so write down the definition. The rate of change of momentum, the rate of change of momentum of a body is directly proportional to the applied unbalanced force. Balanced external force, basically. It is this one. Means if there is a body which is moving, means while it is in the motion, it must have some speed u. This speed have changed to v. For this it is taking some time t. The mass remains the same. Then this change in speed or change in velocity can occur only and only if the external force F is applied. This force must be the unbalanced force. And this value of this force can be calculated by taking the initial momentum, final momentum, and the time. Means measuring the rate of change of momentum. So right, applied force is equals to what? Rate of, or basically it is the proportional sign. So write initially as the rate of change of momentum. So this applied force is denoted by F. Rate of change of momentum, as we have analyzed earlier, delta P by delta T. Now for removing the proportionality, we are taking the value of proportionality constant, and it is found that this value of K is 1. So where K is a proportionality constant, and it is found that its value is always 1 unit. Okay, it means the K shall be replaced by 1 only. So F is same as delta P by delta T. It is this one. But this delta P can be replaced by P2 minus P1. So if there is momentum, means at different states, state 1 and state 2 are given, and the delta T is basically T2 minus T1. It is the complete definition. But substituting in the term of the symbols, because P can be calculated, or P1 here can be calculated by M into U, and P2 at this state. So here we are able to calculate the P2 at second stage, and here we are able to calculate this P1. In this case, the P1 or initial momentum is calculated by taking M into U, and this P2 can be calculated by M into V. Okay, so that can be substituted here. So mv minus M into U divided by the time interval. So this P1 was at time T1, this was at time T2, but the difference of T2 minus T1, it must have some value. Like you have started your journey at 1 o'clock, reach finally to somewhere at 3 o'clock. So the time interval is what? 3 minus 1 is 2. So it is 2 hours. So that 2 hour is denoting this T. So T2 minus T1 can be replaced by T itself. Now taking this M as common, this is again V minus U by T. So this V minus U by T can be replaced by A. So therefore the force F is given by mass into acceleration, where A is acceleration, and this acceleration can be calculated by change in its velocity or rate of change of velocity. So V minus U by T, this was the definition. M denotes the mass of body, and in this case the F denotes the force applied or force generated in the body because of change in its momentum. It is like this. A student, this F is equals to ma is obtained from Newton's second law. So this is all right. This formula gives the measurement of force. So it gives the measurement of force. And how we have obtained this? And it is obtained from the Newton's second laws of motion. Obtained from Newton's second laws of motion. Student, your time is up. What I shall do? I could not understand. So how the force is measured? Force is measured by F is equals to ma. From where this formula we are getting? We are getting from the Newton's second. So Newton's second law gives what? Newton's second law gives the measurement of force. But Newton's first law gives the definition of force. It is that way. A student, what could be the unit of force?
Newton.
So this 1 unit force should be
Kg meter per
applying
second.
this formula. Should be, yeah, first listen carefully. So for 1 unit of force, I need to take 1 unit mass, and then this 1 unit of mass have to be accelerated or have to be given an acceleration of 1 unit. So 1 unit of acceleration is produced in the body. So considering this mass and acceleration in SI unit, it is called as 1 kg multiplied by 1 meter per second square. So it's simply 1 kg meter per second square. Here this kg meter per second square in SI unit. So this unit obtained is called SI unit. And this 1 kg meter per second square is named as Newton.
Newton.
Yes. And denoted by N. So therefore, this 1 Newton is nothing but 1 Newton is the force which is able to generate an acceleration of 1 meter per second square. Students, if we are changing the unit to CGS, so it is our SI unit. So that we have to keep in mind. So SI unit of force is what? Newton. So what is 1 Newton?
1 kg meter per second square.
So this 1 Newton means it is 1 kg meter per second square. It simply means this. So how is the definition? So force is said to be 1 Newton. Force is said to be 1 Newton if it is able to produce, if it is able to produce an acceleration of 1 meter per second square in a mass of 1 kg. Means if you are taking just 1 kg mass, you are applying the force so that the body gains an acceleration or attains an acceleration of 1 meter per second square, then the applied force is said to be 1 Newton. Okay, student? It's simply meant. There is other way. The other unit of force is called dyne. So whatever taking this kg and meter per second square to define the unit of force, it is called as your SI unit. So it was our SI unit of force. The other one is our CGS unit. In CGS unit, we need to take mass in gram but acceleration in centimeter per second square. Then the force that we will obtain is what? 1 gram multiplied by 1 centimeter per second square. Means it is 1 gram centimeter per second square. This term is called as your dyne and denoted by D. Okay, student? So CGS unit of force is your dyne denoted by D. So how is this 1 dyne or 1D? 1D is our 1 gram centimeter per second square. So how is this dyne is defined? So 1 dyne is the force which can produce force applied, or write in other way, force applied on 1 kg. Rather than 1 kg, we need to take now the gram. on 1 gram mass gives or produces acceleration of 1 centimeter per second square. So it is the definition of one dyne. So this way the dyne and newtons are defined. There is a relation between dyne and newton. It is asked quite frequently. So write relation between dyne and newton. So what is that relation? So this dyne denoted by 1D, it is denoted by 1N, but this 1D is our 1 gram centimeter per second square. This is our 1 kg meter per second square. It is found that this 1 Newton is equals to 10 to the power 5 dyne. How is this? That relation we want to develop. So it is quite easy to convert. See, 1 Newton. How is that? It is given by 1 kg multiplied by 1 meter per second square. It simply means 1 kg multiplied by 1 meter. See, per second square, so second square is in denominator. Are we getting like this? To convert it into dyne, we need to convert this kg into gram and this meter into centimeter. So these two conversion are required. So convert this. How is this 1 kg? Relation between 1 kg and gram is that 1 kg is equals to 1000 gram and 1 centimeter and centimeter relation is there. What is the relation? 1 meter is equals to 100 centimeter. So this 1 meter can be replaced by 100 centimeter. Keep the second as it is because in both the case there is second. So second square as it is. Now whatever the multiplication of numbers, you just keep it together. So 3 and 2, 5. So and there is then gram, then centimeter by second square. So you just keep this number as 1, over there is 50, then it is written as gram centimeter. In denominator second, that can be written as second to the power minus 2. Okay, it is this. So this is the relation between this kg meter per second square and gram centimeter per second square. But this gram centimeter per second square is called what? This is called as dyne. And writing this 50 over 1 in the exponent form, this can be written as 10 to the power 5. And this gram centimeter per second square is denoted by D. So this way we have started with N and we have reached to this D. So this implies 1 Newton is equals to 10 to the power 5 dyne. This way we have proved. Okay. But this is asked directly in your MCQs. So 1 Newton is equals to how much dyne, or 1 Newton is equals to how much gram centimeter per second square. It is 10 to the power 5. Okay, student, this we have to keep in mind. Or the reverse is also true. 1 dyne will be how much? 1 by 10 to the power 5 will come in denominator Newton. So this can be written as 10 to the power minus 5 Newton. 1D. Just rearranging this. Okay, now 1 Newton is equals to 10 to the power 5 dyne. So 1 dyne is equals to 1 by 10 to the power 5 Newton. It is written here. So the denominator can be brought into numerator with negative power. So 1 dyne is equals to 10 to the power minus 5 Newton. Sometimes which relation is correct, you have to mark it in MCQs. At that time you have to take carefully. whether in left hand side it is dyne or newton. If it is 1 Newton, then 10 to the power 5 dyne. If 1 dyne, then 10 to the power minus 5 Newton. Okay, so this is the relation. So this was all about our Newton's second law. So what we are getting from the Newton's second law? So
Measurement of force.
good. So Newton's second law gives the measurement of force. So Newton's second law gives. I need to stop the class. I have to go for class 10. So the A, write the option A. Definition of force. The B, is our measurement of force. The C, formula for force. D, both B and C. Yes, student, what is the answer?
B.
Option D. Measurement of force.
Measurement of a force.
And what about C? Formula we are not getting.
D. Both B and C.
Yes. A student, this is from the first law, Newton's first law. This is means F is equals to ma. This is your Newton's second law. This, writing this, how this is the measurement, same. Where the unit of force, even the option D may be framed as unit of force. Unit of force. Then this E is also correct. If E is there, then E is also correct. Okay, student? So this way we are getting the unit of force, measurement of force, formula for force. Getting now? So this thing you have to take care. So this was all about our Newton's second law. Now let us go for the Newton's third law. I think, shall we stop the class? I have to go for class 10th, but how we can finish this? Yes, student? Because just skipping and telling that it is this, you cannot answer any of the question. That's why I had written everything. Yes, students, tell me. So, right, there is another small topic called impulse. So, what is this impulse? Impulse is nothing but it is change in momentum. Change in momentum. Though we have calculated earlier, whatever the change, the same change. Means if the body is initially moving with some speed, say V1, the mass is, you may write this as M. It have attained the new speed V2. At this time, the body have momentum P1, mv1. At this time, the body have momentum P2, m into V2. Okay, students? Then, what is the change? So, if we talk about the impulse, it might have taken some time, t also, we can denote this way. Then impulse simply means we need to calculate the change in momentum. It is not the rate of change, because the rate of change give us the force. So write a note here. What was the force? So mathematically, the force is measured by rate of change of momentum. It is rate of change of momentum. Okay, students? It is like this one. So, students, only change in momentum is our impulse. It is given by P2 minus P1. Now, this P2 can be substituted as mv2 and mv1. So, only this change in momentum is called as impulse, and this impulse is denoted by the symbol J. So this J is given by this one. Sometimes this P2 minus P1 is also denoted by delta P. So therefore, this J means delta P given by P2 minus P1 is also given by mv2 minus mv1. So entire relation is this one. A student, since what is force? Force F is given by delta P by delta T. This we have lower. Then multiplying this F with delta T, we are able to get only delta P. Now this delta P is called as J, means momentum. So this implies this J momentum can be this delta P. It can be your F into delta T also. Okay, just by applying the definition of this force, we have just rearranged it. So it is this one. So this change in momentum can be directly calculated by knowing the applied force and the time taken to change that momentum. Or the other way, it is our P2 minus P1. If applying this definition we are calculating the change, then it is mv2 minus mv1. Okay, student? Now we have to come about the application of this moment. Momentum is basically what? The product of force and the time interval for which the force is applied. So this momentum is also defined as product of force and time interval for applying this force. And write down the and sometimes it starts misbehaving. And time interval in which force is applied. It is this one. So this delta T denote the time interval in which the force, this force is F, so this force is applied. It's simply means, or simply calculated by calculating the change in momentum by calculating the change in speed. Okay, students, so this is the other way of calculating. So these are the two ways of calculating this momentum, or sorry, the change in momentum or impulse. So impulse, it is the definition simply the change in momentum, and can be calculated by knowing the applied force and time for which the force is applied. Now, what is the unit of impulse? So let us write the unit of impulse and momentum. So let us go ahead. Write down the unit of impulse and momentum. We have to understand first the unit of impulse and the unit of momentum. So let us start with the momentum or unit of moment. A student, this momentum is given by mass into its speed. So unit of this, so unit of P, P is denotation of momentum. You have to take unit mass and also the unit speed or the velocity rather. Now consider this mass in SI unit. So what will be the SI unit of this P? So 1 P or 1 unit momentum will be mass in 1 kg and velocity in 1 meter per second one.
Second.
Yes. So student, keep in mind it is 1 kg meter per second. Means the power is your -1. But note, for the force, what was 1 Newton? 1 Newton was 1 kg meter per second. Power was -2. So that you have to keep in mind. Are you getting? So it is our, that is kg meter per second is the unit of momentum. So this is our SI unit. Momentum. If we consider the CGS unit, what are these SI units, CGS unit? We have discussed in our first chapter in very detail. Means in this time, the momentum unit that we want to calculate is given by 1 gram and 1 centimeter per second. So it is given by 1 gram centimeter per second or 1 gram centimeter, writing the second as the power 1. A student, like Newton, it was given certain name, but this gram centimeter per second or kg meter per second, it do not possess any specific name. So just this you have to keep in mind. So it is the unit. Only the thing that you have to understand, it is different from the unit of force, where it was gram centimeter and second was power -2. So this was for the force, but this is for the momentum. So this was also for the force in SI unit. A student, so the unit of momentum we have calculated. Now a student, you just tell me, I have 5 kg of rice and I have added or I have increased the mass to 7 kg. Then what is the change in mass? How much kg? It is 2 kg. What we are observing? The change have the same unit as that of the parent quantity. So right, if we consider the impulse or unit of impulse, so this unit of impulse is same as the unit of momentum. Means what? Change in momentum means unit of momentum 2 minus unit of momentum 1. But we are already knowing, means it is nothing but this was denoted, we were denoting by P2 and it was denoted by P1. A student,
Delta P.
yes, that was giving us the delta P to give the change in momentum. So the unit will also be obtained by taking the difference. So it has some value in, say, kg meter per second. It also has some value in kg meter per second. It may be possible, sir. Let us consider the second P2 as, say, 12 kg meter per second and P1 as 8 kg meter per second. Then taking the difference of this 12 kg meter per second minus 8 kg meter per second, ultimately what we will get? We will get
4 kg meter per second.
kg meter per second. Ultimately what we are getting, even the change have the same unit at that of the parent quantity. Getting? So unit of impulse will be same as unit of momentum. Getting? So this thing we have to keep in mind. Unit of impulse means same as unit of momentum. So right, unit of impulse is also your kg meter per second in SI unit and gram centimeter per second in our CGS.
CGS.
Okay, students. So it was this one. So that's what we are observing. Unit of momentum is same as unit of impulse, or unit of impulse is same as unit of momentum. So right is same as unit of momentum. So it was this. So this is also asked, which of these two quantity have the same unit? It is the impulse and momentum. Impulse was basically the change in momentum, so it poses the same unit. Okay, so this was about the impulse and unit of impulse. Now, a student, let us stop the class here. A student, can we conduct this class tomorrow? Yes, students.
Okay, sir.